invited me to be a lecturer for the Tombaugh Club meeting. And I checked the list of previous lecturers, and it's an impressive list of people and a lot of interesting subjects. I'm honored to have the opportunity to be a presenter and be added to the list of the Tombaugh Lecture Series. So here's my first eclipse in Zambia, Africa. That's my first picture of a corona, a half-second exposure. And despite a massive amount of preparation and reading everything that Fred Espenick had written at the time, and you got to remember, this is before YouTube, and this is before a lot of websites about eclipse information. You got your information from books. But anyway, despite an amazing amount of dedication, I was completely unprepared for the excitement that happens around totality, during totality, and after totality. So my first eclipse, my photography plan got completely disrupted. And this is what I mean. This first image on the left is my first image at second contact in 2001. And I was way late. So we're watching, you know, the last part of the partial phases, and the umbra is coming, and the crowd is going crazy, and the crickets are going crazy, and there's just this excitement. You forget to look at your watch. I mean, you're not going to follow your watch during an eclipse. So what happened, it started in the sky, and I wasn't even at my gear, so I started to take pictures late. So I'm about 15 seconds late for my first picture at second contact. And so then we're watching the eclipse, my wife and I, and it's a 3-minute and 35-second eclipse, and the horizon is beautiful. Jupiter was up there in the same field of view as the corona, so that was beautiful. And the time goes very quickly, and the time got away from me. So again, it starts in the sky, and I'm not even at my gear. So the second image on the right is my first image after third contact, and I'm at the wrong shutter speed. I didn't change my shutter speed from the last shutter speed I was using for totality. So this is basically an overexposed Bailey's beads shot. It shouldn't look like this. I'm about 10 seconds late. So I realized after I got back to the States that something needed to be done to help people photograph an eclipse. So I started to develop the first talking timer, because I knew you needed to have something that was a timer that would talk to you. This way you could watch the eclipse with your eyes. You can keep your hands on your gear, and you would have cues to do what you needed to do when you needed to do it with the countdowns. And a max eclipse call is very important. It's crucial, so you know when you're about halfway through totality. And you could also make other announcements that are interesting about the eclipse. So this is the first version of the talking timer that I developed in 2001 and 2002. And it ran on Windows. And the mobile version was called Windows Pocket PC. And the popular device at the time was the iPack, the compact iPack. So that ran Windows Pocket PC. And this, you can see the form factor here in 2002 is the precursor to the handheld phones we have now. And there was app stores back then to download Windows apps to the compact, and that was Pocket Gear and Handango. And I had this app on that store for people to get. But the problem was this app on Windows was completely manual. So there was no geolocation in the iPack in 2002. And so you couldn't automatically calculate your contact times. So you had to look up your contact times or extrapolate your contact times, and then you had to manually enter them into C1, 2, 3, and 4. And now when you put in C2 and C3, it would calculate the totality duration for you, but it wouldn't calculate max eclipse. So you had to do that manually too. You had to take the time of totality, divide it in half, and then add those seconds to second contact, and that would be your max eclipse time, and you had to enter that manually so you would get the max eclipse call. So it was cumbersome, but again, it was the first one. And so I also started the concept of using the timer to make announcements about the partial phase phenomena. So this first timer announced to observe for temperature changes 3 times. It announced to observe for ambient lighting, animal behavior, and shadow bands. And I also started the concept, the feature of having a data saving file system so that you could save the information about your observing position, your coordinates, the contact times, elevation, the GMT offset, and then notes about the observers you saw the eclipse with. So we developed a timer and we brought it back to Africa in 2002 in Zimbabwe this time. And the timer worked great. It actually was very helpful, and it performed as it was developed. The problem was there was an error introduced by needing to figure out the contact times for your observing location in 2002. So here's our setup. And down here, you can see this little red circle. We had little battery powered speakers hooked up to the iPac, and it was playing the announcement for us. And this was a short eclipse. It was 1 minute and 23 seconds. So having the announcement for max eclipse to know when it was half over was very helpful. But the way you prepared for an eclipse in 2002 was by ordering a NASA bulletin from Fred Espenick in Goddard Space Flight Center. So you would send him a self-addressed stamped manila envelope, and he would send you back the paperback bulletin for that eclipse. And it had paper maps in it. And as you kind of drill down, the maps would get more and more detailed, but this is the detail you would get. These little circles are the umbra every 2 seconds. And then the data presented with that circle is the totality duration at that circle and the altitude of the eclipse at that circle. That's all the information you got from the maps. To get contact times, you had to look at the list of major cities. So the contact times had the coordinates and the contact times for the major cities, but you couldn't get it anywhere along the path. So you had to take this information and somehow extrapolate it to your observing position. Now, we had GPS at our observing position in 2002, but for some reason it wasn't very accurate in Africa in 2002. And I was with Bill Kramer, and Bill Kramer can do the contact math manually, amazingly, but he can. Or you had to have a computer like NASA would have that could have the computation in the computer, and you could put your coordinates and spit out the contact times. That's how Fred would publish the books. Or in some way, you would have to analog, in an analog fashion, you'd have to extrapolate it from the maps, but it's hard to do. So when I watched the videotape that I had of the eclipse, a zoomed in videotape of the eclipse, and I listened to the timer talking in the background, we were off by 5 seconds. We were late by 5 seconds with our manual contact times because everything was happening in the sky 5 seconds faster. So the next eclipse I went to was on a cruise ship in the Mediterranean Sea in 2006. So there's no sense in using an accurate timer there because you're on a moving ship. So you can't really drill down to second timing. But then game changers happened that set me up for 2016 to change the app to a mobile device for the 2017 eclipse. And of course, that was the iPhone being introduced in 2007. Xavier working with Google Maps to make the path interactive on Google Maps in 2004 and 2005, and then 2008 working with NASA to make a NASA interactive map. And then, of course, YouTube starting in 2005, which allowed a lot of people to share more information about eclipse chasing and allowed me to start my first educational YouTube channel myself.